Good evening. I will be ripping off this 555 result is getting so let's just start with a new KiCAD project. And the first place we're going to want to start is the schematic. If you want to be really formal, you can fill out your sheet, but I'd rather just jump to dropping stuff in place. Components are going to be making up this circuit. So in this circuit, that would be the 555 timer, 3 resistors, a capacitor, and an LED. The other symbols on the schematic, the voltage source and ground, are also things we'll need to represent on our schematic, but they're not components, so they won't be in the symbol library. So you can just start by putting in a search term. So here's a 555, but if you know what you're looking for, there can be a couple of variants, and probably out of scope for this quick intro, but if you need to, you can create your own schematic symbols and footprints for devices that aren't included. So let's just put that guy right in the middle. You can rotate parts by selecting them and pressing R, which can kind of help you get all of the things on the right side to connect. Alright, so let's continue by adding the rest of those pieces. The US resistor symbol is called R_US, and because I've got a couple of these, I'll just press Ctrl C and Ctrl V to copy and paste. Now let's go for the LED. There's all kinds of options in here. You have RGB LED or something like that, but here's the most simple one, and because these guys are directly connected, I can just plug them together straight away. Likewise with the capacitor, I like we could use this symbol, but I think so if I really wanted to clean up the schematic, I might make sure all the spacing is even. It might be better to choose a different footprint, or I'm sorry, a different symbol in the schematic to stop having so many cross lines. The arrangement of the pins in the symbol really helps keep the schematic clean. But I think that's correct. So now the next part we'll want to do is label all the devices. These labels carry over to the PCB design. We can actually, if you want to semantically keep the information about your circuit all together, we can actually fill in the value fields for these components. These won't necessarily be printed on the PCB, but you can move those fields there. Whoops, we want to modify the resistor, not the text field. And this capacitor will be all right, looks good to me. So now that we've got our schematic finished, I'll maximize this now. We are basically done with the layout of our circuit, and now it's time to put it onto a printed circuit board. So the layout of the pieces may have nothing to do with where they're located on the printed circuit board, but what we do need to do in the schematic is associate each component with a footprint. That determines if it will be surface mount or through hole, what size it is, how the pins are physically arranged, which doesn't have to match the schematic, but let's do that part. So we're looking through the footprint library, and we want to find components that we actually can use. Their measurements, how the pins are arranged, that's what the footprint is. So this is a resistor I've selected. So let's go to, let's see, resistor through hole, THT. And of course there's a lot in here. You can kind of go through them. Whoops. So we're not using a resistor array. We're going to be using an axial resistor probably. So let's go with something about 5 millimeters long. My resistors were about that length. I just kind of like this symbol better. You have some choices, and of course you can also draw these footprints. So let's go with that footprint, and I'll make all the resistors the same. All right, for the LED, there should be an LED through hole library. So I think 3 millimeters is kind of a tiny LED. Maybe you'll have a 5 or 8 millimeter LED. An 8 millimeter LED actually seems pretty big. But I'm just going to go with the 3 millimeter. I do have some of those laying around. As for the capacitor, that should be where at? A through hole capacitor. There are tons of sizes for capacitors, but we can just kind of guess. It's going to be, that doesn't look quite right. Let's go with a radial capacitor. You can imagine that the two legs sticking out of the bottom for this polarized capacitor will be put onto these two pin holes, through holes, and the mark on this symbol that will show up on the silk screen of your PCB will indicate which way it's polarized. And we have some spacing choices. 2.5 seems about right. but consult your datasheet. Finally, we have the IC, and you won't really find a 555 timer footprint in the library. What we really want is a package, and because I'm still a newbie, I'm going to go with a dual inline package.